Okay, so the next lesson that we're going to talk about is trapezoids. So for trapezoids, we have to know a few things. First of all, what is a trapezoid? So a trapezoid is a type of quadrilateral, meaning four-sided figure, that has one pair of opposite sides being parallel. So in this example, we see that this side and this side are parallel, as indicated by the arrows. Okay, it's different from a parallelogram because parallelogram would have another pair of sides being parallel. So in this case, we only have the one pair. Another key feature for trapezoids is that consecutive angles are supplementary. And so it's not just any two angles that are next to each other, but rather it's the two angles that happen to be on opposite parts of the parallel. And this really is what we have been calling same side interior, also known as consecutive interior angles, right? Because if we set this up as a transversal, right, these two angles are said to be consecutive interior, right? And same thing applies if we use this as a transversal, right? We have these two angles being same side interior. So if you call these angles A, B, C, and D, we would have that angles A and B have to add up to 180. And same thing for angles C and D, they would have to add up to 180. Okay, so we're going to want to keep those concepts in mind. And the next thing to look at here is isosceles trapezoids. So sometimes we might get a special kind of trapezoid, right, whereby we have, of course, the parallel sides, which are required for it to be a trapezoid, but then we also have the other pair of sides being congruent in length. Okay, so the non-parallel sides are congruent, and a couple more features to talk about. First of all, the diagonals of this shape are going to be congruent, okay, and what are known as the base angles are going to be congruent. So the base angles are these guys, right? So those are going to be equal. And in the case of the isosceles trapezoid, we also have opposite angles being supplementary. And what that means is basically, yeah, if I knew that, let's say I knew that this was 80 degrees, right, then we would know that this would have to be 100, this would have to be 100, and this would have to be 80, right? That comes from the fact that consecutive angles have to add up to 180, and the base angles have to be equal, which means that these top angles would also be equal, etc. Okay? So let's go into the questions and see how we could do with this. First question. So given that this is 87, we could always do 180 subtract 87. That leaves 93 to go here, right? And same thing for 51. We would do 180 minus 51, and that would leave 129 to go in here, right? So 129 and 93. Okay, so for this one, notice that the parallel lines are going this direction. So you could identify this as a transversal, and we know these are same side interior, which means they have to add up to 180, right? So we could take these two expressions, add them together, and set equal to 180. So we have 8x plus 60 is 180. We subtract 60, and we get 8x is 120. Divide, and we get x is equal to 15, right? Next, so this time we have an isosceles trapezoid, so we have those extra properties, being that the diagonals are congruent, for example. Let's see, so DG would have to be congruent with EF, right? And then DF would have to be equal to GE, right? So that's the definition of an isosceles trapezoid, is that these are equal, and then an extra result we get is that the diagonals are equal. All right, and then number 7. So again, we can see that this is an isosceles trapezoid. Isosceles, because of the lines that indicate the lengths are equal. So the first thing I would do is I would do 180 minus 112, and that would get me 68 degrees to go here. And then I know the base angles are equal, so that's also 68. And then this one would also have to be 112, since these angles have to add up to 180. All right, so Q is 112, angle R is 68, and angle S is also 68. All right, so now it's your turn to try the right-hand side.